Hey, what's up everyone? In today's video, we're going to take a look at another development board, which is called the NodeMCU ESP8266, and it has Wi-Fi capability. Unlike the Arduino, in order to use Wi-Fi, you have to bring a Wi-Fi module. We have some GPIO pins that we can use for some projects. For example, we can connect some sensors, like the gas sensor to detect the gas, and we can connect output devices to turn them on and off. We're going to program it using the Arduino IDE. As you can see, we have this USB port. So I'm going to connect it to my computer using the micro USB cable. I've already used a blink sketch to turn the built-in LED on and off, which is this blue LED. If you want to check out the GPIO pins, I have this circuit schematic diagram. Its blue built-in LED is connected to the GPIO pin number 2 that we're going to use in our code. But first of all, we have to download the Arduino IDE from this website. I'm going to add it under the video description. At this moment, we have the version 2.1. If you are using the Windows operating system, make sure to select one of these options. I'm going to use the top one. The same thing applies for the other operating systems like Linux or Mac OS. So let's click on this link. Then I will just download it. And once it's done, we can open up the file, or you could go to the downloads folder and double click on it. Then let's hit agree. I'm going to use the top one so that anyone can use the software, and hit next, and let's hit install. And there you go, we can run the Arduino IDE by selecting this option and hit finish, or you could open it up from the desktop icon. So by default, we could only program Arduino boards like the Arduino Uno, but to be able to program our ESP8266, you have to go to File, then Preferences, and here we have Additional Boards Manager URL. Basically, it allows us to use other boards like the ESP32 or the ESP8266. For that, you will need to copy this link. I'm going to use Ctrl+C, and let's get back to the preferences, and make sure to paste it. I've already done that, but if you already have other URLs, you can separate it with a comma and paste it. Then let's hit OK. But that doesn't add anything to the Arduino IDE. We have to install the package by going to Tools, then under Board, we have Boards Manager. Just write ESP8266, and here it is by community. I've already installed it. Make sure to hit the install button. Once you do that, you will be able to select other boards from Tools. Then we have Board. At the bottom, we have the board that we are using, but you will see a few options because we have different versions. For me, I have a NodeMCU. That's why I'm going to select this option. To make sure that everything is working just fine, I'm going to upload this empty sketch by hitting the upload button. Here we have compiling. If you get this error, don't worry. That's because we haven't selected the port of the USB cable. To select this port, you have to go to Tools, then Port. Here we have few options. If you are asking how to get the right port, you can unplug the USB cable, then get back to the port section. You notice that COM7 disappears, and that's the one that we're going to use for our USB cable. So let's plug it again, then select the port COM7, and let's try it again. If you got this error, you may need to install a driver which is called CH340. By going to this link, you could download it for Windows as well as Mac OS and Linux. For Windows, we have two options. We have the newer version from this link. And if you are using Windows 11 like me, you will need to install the older version. Then you will be able to upload the sketch. And there you go, we have connecting. After that, it starts uploading. We have the percentage. Let's try another sketch, which is called the Blink sketch that comes with the package. By going to File, Examples, and select ESP8266. The top one is called the Blink sketch. Let's open it up. Basically, we have few commands like the pin mode to set the pin mode. In this case, it is an output device so that we can turn it on and off. And the first parameter is the pin number that is connected to our built-in LED. But the loop function is called over and over again. So each time we can turn the LED on using the digital write command that takes the pin that we want to control. Then we have low to turn the LED on. After that, we wait for a second and turn it on using the high keyword. And finally, we wait a bit And that's how the blink sketch works. Then let's hit upload. If you have any question or comment, make sure to write it under the comment section down below. One of the big advantages of these development boards, these pins that we can use to connect some devices. These devices could be output devices like an LED so that we can turn it on and off. And the second option is to use the pin as an input. Normally we use it for sensors. For example, we can check if we have an obstacle. Also, we have the gas sensor that we use to check for gas leaking. I'm going to show you how to use the pins in these two modes as an output to turn the LED on and off. For that, you will need this red LED as well as an ohm resistor like a 220 ohm resistor or 300. Of course, to connect these components, we're going to use the breadboard and few jumper wires. But before that, let's take a look at the pins using this pinout diagram. As you can see, these pins are labeled like D0, D1. D stands for digital, which means 1 or 0. If we use this pin as an output, we can output a voltage using 1 or set it to 0 volts using the value 0. The same thing applies for sensors. We can read 1 or 0. Inside the code, we can reference these pins using the notation D1 or D2, or you could use the number of the pin, like the GPIO pin number 5. Next, we have few pins that are labeled 3.3 volts or G and E. Normally, we use these pins to power up some sensors. On the top left corner, we have a pin that is labeled A0, so A stands for analog. Last but not least, I want to talk about these two pins. This is called the VN, which we use to power up our ESP8266. For example, we can bring this 9-volt battery and connect the VCC, which is the positive lead, to the VN, and the GND to the GND to power it up. First of all, let me show you how to use the first mode, which is called the output mode, to turn on and off the LED. For example, let's use the digital pin D2, or it is the GPIO pin number 4. To do that, I want to mount the ESP8266 on the breadboard like that. And let's take one of these jumper wires. As I said, I'm going to use the pin D2, and let's connect the other side to this point. Then to connect the cathode pin or the positive lead, we have to put it in the same column. If you don't know how the breadboard works, basically all of the points in the same column are connected, like these 2 points, so that we can connect the positive lead to the digital pin number 2. And you notice that we have this line because all of the points on the top side are separated from the bottom side. Finally, I want to connect the negative lead or the anode pin to the ohm resistor, and the other side will go back to the ground using one of the G and D pins like this one that is labeled G. We have to put it in the same column. Finally, we can connect the USB cable so that we can program our board. First of all, we have to tell our ESP8266 that we want to use this pin as an output so that we can control the LED. And to do that, we have to use the pin mode function or command under the setup function, which is called once. By writing the command pin mode, this takes in 2 parameters. The first one is the pin number, and the second parameter is the mode. This could be output, and all of the letters are uppercase. Later on, we're going to use the keyword input for the sensor. And at the end of each command or instruction, we have to add a semicolon. Now to turn the LED on, we have the command digital write. The same thing, it takes 2 parameters, the pin that we want to control, and a digital value, which could be 1 or 0. 0 means 0 volts to turn the LED off, and 1 means 3.3 volts to turn it on. But I recommend you to use other keywords like the high keyword, which means a voltage. Now let's give it a try. After selecting the right port and the port of the USB cable, and let's hit upload. And yep, the LED turns on. Let's try the other keyword, which is called low or 0 volts, and hit upload again, and the LED turns off. Last but not least, I want to make the blink sketch, but we are going to make it from scratch. Basically, we will use the loop function, which is called over and over again, and each time we can turn the LED on using the same command digital write, and I'm going to use high to turn it on. Then we wait a bit, like for 1 second, using a command which is called delay, This takes the number of milliseconds, like 1000 milliseconds, which means 1 sec. Then we turn it off using digital write low, and we wait for 1 second again. Because we have all of these lines of code inside the loop, which is called over and over again, we will have a blinking LED. And there you go, the LED is blinking each second. Finally, we can talk about the other mode, which is called the input mode, which we use with sensors, like this obstacle avoiding sensor. So let's take a look at these pins. Here we have the VCC and the GND. We are going to connect these to the 3.3 volts and the GND of the board to power up this sensor. And finally, we have the output pin, which outputs a voltage according whether we have an obstacle or not. We have to hook it up to one of the digital pins. Then we can use a digital read command to read the voltage. If we get 1, that means we have an obstacle. And if we read 0, it means that nothing in front of it. But there is another version of this sensor that works oppositely. If there is no obstacle in front of it, we read 1 or a voltage. Otherwise, we get 0. So let's double check. I'm gonna hook it up to the breadboard and start by connecting the VCC to the 3.3 volts, like this one. And the GND goes to the GND. You could use one of these points because they are connected to the ground. And there you go, it is powered up. Now if I put my hand in front of it, the other LED turns on, otherwise it turns off. That means our sensor is working. But we are going to get this value from the other pin. Let's connect it to one of the digital pins, like the digital pin number 1 or D1. First I'm gonna go under the setup function so that we can add the pin mode. This takes the pin, like D1, and the input keyword, because we have a sensor. Under our loop function, we are going to read the value of the sensor using the digital read command. If we get the value 0, we're going to use the blink sketch. Otherwise, we are going to turn it off. So I'm going to cut it using Ctrl X. Then we can use if to check for something. So if digital read, this takes in the pin number, which is D1, and it returns a value that could be 1 or 0. If we have the value 0 using equals 0, in such case, we're going to turn the LED on and off. Otherwise, we are going to turn it off using else, which means if we get the value 1, I'm going to use this to write, and the low keyword, which means off, then hit upload. At this point, the LED is off, and if I put my hand, you see it is blinking. So if we have an obstacle, we get the value 0, otherwise we get the value 1. That's why the LED is off. We're going to talk about one of the best features of the ESP8266, which is the Wi-Fi capability. We can use it to control some devices wirelessly. But first of all, we need to understand how the Wi-Fi capability works. Basically, our ESP8266 will be connected to a router or an access point. And to do that, we have to provide it with the name of the router or the network and its password. After that, we can use all of the devices that are connected to the same network, like the computer or your smartphone, to control some devices that are connected to the ESP8266. In this video, we're going to use the LED. We'll be able to turn it on and off from a smartphone or the computer. And this mode is called the station mode, in which our board gets connected to the network like any other device. But we could use it as the access point, which means our microcontroller will create its own network and gets connected using the name and the password that we can set from the code so that we can control the LED with the same way. Also, we can combine these two methods to make some cool IoT projects. We can use our ESP32 in station mode and the ESP8266 in access point mode, but that's another topic. First of all, we're going to talk about the access point mode, in which we are going to provide the SID and the password in the code. Luckily, the ESP8266 package comes with a few examples that we can use and understand how things work. To do that, we can go to File, Examples. We have ESP8266 Wi-Fi, like this sketch, which is called the Wi-Fi scanner. This will print all of the Wi-Fi networks that are located around the ESP8266. On top, we have to include this Wi-Fi library. Then under the setup function, we have serial.begin to initialize the serial monitor, so that we can print the available networks and some information. Next, we have this method, Wi-Fi.mode to set the mode of the board, which is Wi-Fi station mode. The next method is Wi-Fi.disconnect. So in order to get the available networks, you need to be disconnected. And under the loop function, which is called over and over again, we have this Wi-Fi.scan networks, which returns an integer. If it's 0, it means that there is no networks. Otherwise, we can print some useful information like the SSID, which is the name, whether it is encrypted or not. Now, enough me talking about this. Let's give it a try and check the result. You don't have to provide any kind of information because we are scanning the networks. Let's hit the upload button after selecting the board and the port of the USB cable. Once it's done, you have to open up the serial monitor to check this information. So we have 3 networks found, and these 2 are mine. We're going to use this one as the access point, which is called our network, using file, examples. And let's go under ESP8266 Wi-Fi or web server. And we're going to select the first one, advanced web server. In this sketch, our ESP32 microcontroller gets connected to a router or an access point using the name and the password. Then we can access its web server to turn on and off some devices that are connected to the ESP8266. We can use a smartphone or a computer. If you don't know, each device in this network has some kind of IP address that we can use to access each device or communicate between these devices. This IP address is going to be printed on the serial monitor so that we can type it inside a browser using our computer as an example. I highly recommend you to read about this sketch. It's really important. First, we have all of the libraries that we need. Then we have these 2 parameters. The first one is the SID. I'm going to use my own, which is called our network, as well as the password. Then these 2 values are assigned to these variables, the SID and the password. And to create the server, we have this object of type ESP8266 web server. Then we can use it to set some routes, which is like a link, like the IP address /. When you enter that link, you will get an HTML page with some information. And all of that is set under the setup function using server.on, which takes in 2 parameters. The first one is the link, which is the IP address /. Whenever you enter it, the function handle root will be called, which is going to display this HTML page that we can see inside the browser. Anyways, once you set the SID and the password of your network, we can give it a try. Once it's done uploading, we can open up the serial monitor and make sure to select the same baud rate that is used under the setup function, which is 115/200. I'm going to reset the board using the reset key. Now it's trying to connect to the network. And there you go. It is connected and we have the IP address that we have talked about. Let's copy it using Ctrl+C. As I said at the beginning of the video, you have to be connected to the same network, our network. And you can open up a browser like Microsoft Edge. If you paste the IP address and hit enter, we have this interface that contains some information like a title. We have this timer as well as a graph. It is just for testing purposes. These values are random, but you could replace that with some readings from a sensor, like a real-time temperature and the humidity. Now we can move on to the next step. I want to control this LED that is connected to one of the pins using a link from this HTML page. For example, we can add an on button to turn the LED on and an off button to turn it off. And to do that, we can get back to the code. First, we have to modify the HTML page, which is like a programming language that is used to display some kind of page. These are called tags. For example, the image tag is used to display the image, which is this graph. Let's go on top. To add a link, we have a tag that is called A. I'm going to print the text on to turn the LED on. Let's add another one. I'm going to use Ctrl+C and Ctrl+V. The text will be off. Also, you have to add the slash at the end of each line, or you will get an error. But at this point, we haven't set a specific link for the on button or the off one. To do that, we have to pass in some kind of parameter, which is called href equals, and in these single quotes, we pass in the link like /on or /turn on. The same thing for the other tag. Let's add href equals and the link /turn off. Now let's check it out. And once you refresh the page, you will see these two links. This one to turn the LED on. If you press it, we are going to go to the IP address /turn on that we have set under the href attribute. The same thing for the off link. The response of the server is file not found because we haven't set the route or what the server will do after we go to this link. But first of all, I want to connect this LED to one of the pins, like D5, using this jumper wire. Then we can connect it the positive lead or the anode pin. Finally, we have to get back to the ground through this ohm resistor to protect the LED. And let's start by setting the pin mode by adding a variable const int and call it blue LED equals D5. And we have to write the pin mode under the setup function. This takes the pin number, blue LED, and the output keyword. I've talked about that in the last video. Make sure to check it out. Finally, we can tell our server to turn the LED on when we go to the route /turn on. And the way we achieve that is by writing server.on. So let's add it under here, which takes two parameters. The first one is the link /turn on, and the second value is the method that we're going to call each time we go to this link, which we're going to use to turn the LED on once we click the on link. But there is another option. You could write the code under here by adding these square brackets like this and the parentheses. After that, we have to open and close these curly braces and write the code that we want to execute once we click the link. So we have to call the digital write command to turn it on, which takes the pin, blue LED, and the high keyword that outputs a voltage from that pin. Optionally, we can send something to the client, like the LED is turned on, using server.send. So let's copy it and write the text that we want, like LED is on. Because I'm a little bit lazy, let's copy all of these and add the route for the /turn off. In this case, we're going to use digital write low and send the message LED is off. And that's pretty much it. That's how we can use the Wi-Fi capability to control some devices that are connected to the board. Instead of using this IP address, that's a little bit hard to remember, we can use something that is called MDNS, which is a service that allows you to set a specific name to access our web server. We can write this name, ESP8266, then we add .local, and there you go, we have the same result. If I click on this link, the LED turns on, and we have this response with the same way we can turn it off. So I hope you liked this video. If you have any question or comment, make sure to write it under the comment section down below, and I will see you in the next one.